Okay, as we work through this, there are a few problems we're going to do in the book, but mostly it's going to be problems that I'm creating or that you're going to research on the internet, like research bank loans, what their interest rate is at the current time, and then if you gotta, maybe you search Zillow and see what houses are for sale and just see what the monthly payment would be with different circumstances. So we're going to do that mostly with this. So we're going to have to know the formulas or have them written down so we can use them, but we have to know how to use them. But this isn't the only way exponential functions are used for. I wanted to show you this, that exponential functions are used all over. So they describe a variety of naturally occurring things, like it can describe the decay. Like I know in science you probably talk about the decay rate or the growth rate of. The decay of radioactive isotopes or the natural cooling of substances, that's all exponential functions. They also model things such as interest earned or the population growth over a certain period of time. Now again, this is just a few things. There's so many ways that exponential functions are used in our real world. So we're going to do that. Now, part of our problems that we're going to be in the book is going to be able to write the exponential equation. Now, a lot of the car loan and mortgage and compound interest is you're going to be given everything, and you have to just know how to solve the equation and figure things out using the equation. In this case, we're going to be given two ordered pairs, and we have to find the exponential equation so we can write it. So y equals a, b to the power of x. X is our power, b is our base, and a is our constant. It's how quickly that exponential function is increasing, or how quickly it's increasing, or how slowly it's increasing is what this value is affecting here. But essentially, we need to write the exponential function. So we are given potential values of x and of y. So we need to solve our equations for one of our variables, either a or b. I'm just checking to see what the book says to do first. Alright, so the book says when we write exponential functions, we're going to take one of those. I'm going to take 2, and we're going to first solve for a, because it's the easier variable to solve for. So we're going to have y, let's take 2 first. I'm going to take 2 equals a times b to the second power. Okay, so to solve for a, that means we can get a by itself, so divide both sides by b squared. So we'll have a divided by b squared, 2 divided by b squared equals a. Alright? Okay, so we have a. So then what we do is in that, we take that and we substitute that in for a here. So we essentially have y equals 2 over b squared times b to the power of x. You want to say, well, you just used 2. We did just use 2 for x, but we're not using that point anymore. And now we're trying to solve for b, so we're going to use our other ordered pair to solve for b, and that is 3, 4. So I'm going to do 4 equals 2 divided by b squared times times b to the third power. Okay, now using our rules of exponents, we should know that, or even multiplying fractions, that 2 divided by b squared times b to the third, this is essentially b to the third over 1, so I can multiply straight across. So it would be 2 times b to the third over 1 times b squared, which is b squared. And rules of exponents is you subtract, so it's going to be 4 equals 2b, because 3 minus 2 is 1b. And then divide by 2, and we get 2 equals b. So then, we have what b equals, so now I can take b and use that and solve for a in this equation right here. So b is 2, so this is essentially 2 over 4, because 2 squared is 4, which is a, so a is 1/2. So our formula is y, for these 2 points, is y equals 1/2 2 to the power of x. And by all means, I'm going to log into Desmos here so you can see how that worked for us. Let's see. So Desmos, y equals 1/2 times 2 to the power of x. So if I zoom in, you should see how 2, 2 is an ordered pair that falls on that line. So right there is 2, 2. If I can hit it exactly, there we go. There's 2, 2. And then the other point was what, 3, 4? And right here is 3, 4. So that shows how it hits 3, 4 as well. So showing us that line falls on those 2 points, so therefore there's our equation. And then we can do that with the other 2 points as well. Same thing, always solve for a first. It's going to be your easier equation to manipulate, so that's the one you want to solve for. We'll do 2, 4. It really doesn't matter if you use 3, 16 first or 2, 4. Either way works, you'll get the same answer. So I'm going to say 4 equals a times b to the second power. Again, solve for a, so divide by b squared. So we'll have 4 divided by b squared equals a. So we're going to take that and we are going to plug it in for a here. So we're going to have y equals 4 over b squared times b to the power of x. I'm going to use my other ordered pair, so 16 equals 4 over b squared times b to the third power, which once again very nicely gives us 4b to the third over b squared. So that cancels out to 4b, which divided by 4, we get 4 is b. And then we can plug that in here and we'll get 4/16, which is 1/4 a. So our equation is going to be y equals 1/4 4 to the power of x. So yes, these are 2 points that fall on this line, but that is the line. There are more than just those 2 points. So that's why we have to continue to use y and x in the equation.